To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today also I am going to continue with some extra questions related to electrochemistry. So in the previous chapter also we started discussing questions where you need to write the answers. So in that, this is extra question 16. The first one, what is the raw material used in the industrial extraction of sodium metal? So you all know students, sodium metal is a highly reactive metal. If you look at the activity series, potassium, sodium, that is the second metal in the activity series. So it is highly reactive. Because of that, electrolysis is the process that is used to extract sodium. And in that you can remember, in the industrial process, we use a special cell called the Downs cell. And in that, sodium is extracted from fused sodium chloride or molten sodium chloride. You all know we get sodium chloride from seawater in the form of a solid sodium chloride, that is salt. And to get the fused or molten sodium chloride, we need to melt the sodium chloride solid. And you are familiar with that, students. Now the melting point of sodium chloride, that is the pure sodium chloride, is about 840 degrees Celsius. Now that is a very high temperature. So we will need to provide a lot of energy. To reduce that melting point, what do we do? In the industrial process, what they do is they mix calcium chloride, about 40% of calcium chloride, so that the melting point decreases to around 600 degrees Celsius. So that is how we use the raw material. But here, since the question says, what is the raw material used in the industrial extraction of sodium metal? You can just write fused sodium chloride. So here we can say fused sodium chloride or you can even write it as molten sodium chloride. So that means it is NaCl liquid. Only the ions present are sodium and chloride ions, Na plus and Cl minus. So then, the second question. What is the name of the cell used for this extraction process? I already mentioned to you all, it is the Downs cell or Down cell. Down cell. Then, what is the next question? Write the anode and cathode of the above cell. So just to recall what happens there. Now here, if you consider the anode and cathode. Now at the anode, what is the reaction? It is oxidation. So in the liquid, sodium and chloride, what undergoes oxidation? It is Cl minus. You can remember Cl minus ions, those are in the form of liquid, become Cl2 gas, losing 2 electrons. And where does this happen? This happens near the graphite electrode. Graphite electrode. So this is a graphite electrode. And what is the charge of anode here? It is positively charged. So here it is positive. You can remember. Anode oxidation happens and anode is positively charged. That is why the chloride ions get attracted towards the anode. And it is made up of graphite. Then, if you take the cathode, the reaction near cathode, you all know, is reduction. And in the down cell, cathode is negative. So there are sodium ions, Na plus ions get attracted to the negative electrode. They take up electrons and become sodium liquid. And here the sodium metal does not react with iron. So we use a steel circular cathode. Circular steel cathode. You can remember that. So here it is a circular steel cathode. So I have explained this to you all students. We have the carbon graphite rod in the middle like this, and around that there is a perforated circular steel diaphragm so that it prevents the mixing of chlorine gas with the sodium liquid that is produced. Then around that we have the circular steel cathode. So that is where the reduction occurs. So you have to remember that, students. Anode is graphite and cathode is the circular steel cathode. So to answer the questions given here, write the anode and cathode of the above cell. So if we do that, anode is graphite, anode graphite, and cathode circular steel cathode. So even here we can say graphite anode. And like I said, graphite anode is positively charged, the circular steel cathode is negatively charged. So we don't need to write that because they have asked for the anode and cathode of the above cell only. Is that clear, students? So with that, I'll move on to the next slide. The fourth part of the question. The anode and cathode of the above cell are separated by a perforated circular steel diaphragm. Why? So I told you all this. Now sodium is a highly reactive metal and chlorine gas is produced as a byproduct. Now if they existed inside the same cell, the sodium liquid will react with the chlorine gas. So again they will form sodium chloride. To prevent that, there is this perforated circular steel diaphragm that allows the movement of the ions. Chlorine gets oxidized at the anode and sodium gets reduced at the cathode. And since they are both separated, there is no way sodium can react with chlorine. So the advantage of having this particular diaphragm, or why we have the diaphragm, is to prevent the reaction of liquid sodium with chlorine gas produced. So we can say to prevent the reaction of liquid sodium with chlorine gas that are produced in the cell. So main thing, to prevent the reaction of the two. Then, so here, fifth part, what is the byproduct of the above process? Already I have told you all, chlorine gas is the byproduct. So it is chlorine gas. Chlorine gas. Then I'll move on to the next slide. Now here, it is extra question 17. Write 2 uses of sodium and also write 2 uses of chlorine. So can you all recall the uses of sodium? Sodium, we use it in the laboratory. For different laboratory experiments, we use sodium. Then you can remember, we use sodium vapor lamps. As street lamps, they use sodium vapor lamps. For that, we use sodium. Production of sodium vapor lamps. And also, it is used as a coolant in nuclear reactors. So those are some uses of sodium. You can write any 2 uses. So here I will say used in laboratory experiments. Then we can say used to manufacture sodium vapor lamps, or used to manufacture sodium vapor lamps. Now here students, you all can write the other one also. Used as a coolant in nuclear reactors. That is also possible. So here used in laboratory experiments, used to manufacture sodium vapor lamps. Those are the uses of sodium. Then write 2 uses of chlorine. Can you all think of the uses? Now to bleach paper, pulp, cloth, for all those we use chlorine gas. Then it is bubbled through water to destroy microorganisms, bacteria. So then to clean the pools, swimming pools, cleaning of swimming pools, they use chlorine. And also I have told you all, usually the water that is supplied to the household, that is also purified, destroy the microorganisms in that, mainly the bacteria in the water that is distributed to the households are removed using chlorine gas. Then there is polyvinyl chloride, that is PVC, which is a polymer. So this particular PVC is available as plastic and PVC pipes and all those objects. So there also to manufacture PVC, we use or we need chlorine gas. So like that, there are many uses of chlorine. You all can write any 2 uses. So first one I will say bleaching of paper, pulp and cloths. Then manufacturing PVC, polyvinyl chloride. So this is polyvinyl chloride, PVC. So I have written 2 uses, bleaching of paper, pulp and cloths, and also manufacturing PVC, that is polyvinyl chloride. You can write cleaning or disinfecting drinking water by destroying bacteria, cleaning of swimming pools. Like that you can write any other use as well. Even the manufacture of hydrochloric acid, HCl. For that also chlorine is used as a raw material. That also can be written here. So any 2 uses of chlorine gas. So with that students, I'll move on to the next question. Extra question 18. The first part, what is electroplating? Plating an object with a metal is using electrolytic cell is known as electroplating. So that is what you need to write here. Plating a metal on an object using an electrolytic process is known as electroplating. So instead of saying plating a metal, you can say applying a coat of metal over another object using an electrolytic process is known as electroplating. Plating or applying, here when we say apply, it doesn't mean you paint it or just dip it into a metal, but instead you have to use an electrolytic process. So you can remember, students, usually we attach the object to the cathode, and the metal that is going to be plated has to be the anode, and the electrolyte solution should be a salt of the metal that is going to be plated onto the object. So that is how we use the electrolytic cell there. I'm sure you all can remember that. And you know examples also. Plating nickel onto iron, chromium onto iron, then copper plating, gold plating, silver plating. These are all different types of electroplating. They all depend on the metal that is plated onto the object. I'm sure you can remember that. So then, the next question. Draw an electrolytic cell to explain the 4 important considerations of electroplating. So what I mentioned now also. The object has to be connected to the cathode. The metal that is going to be plated should be the anode, and the solution, electrolyte solution, should be a salt of that particular metal. And also, by convention, you all know, students, the positive and negative electrodes, based on how you connect them to the electric power supply. Now you connect the positive terminal of the battery to the metal, then that becomes the positive terminal, and usually that undergoes oxidation. And the negative terminal, the metal or the electrode connected to the negative terminal, becomes the negative electrode. And that is where reduction takes place. So you have to remember that. So if we are to draw the cell, now here we have the electrolytic cell with the electrolyte solution, the electrodes, and you need to have the power supply, positive, negative. Now let's say this has to be the metal to be plated. Why? This is going to be the positive electrode where oxidation takes place. So this particular metal will dissolve. Then you all know here we need to connect the object. So this has to be the object. Now this is the negative electrode, and that is going to be the cathode, and the object is connected to the cathode. Or else if it is something like a spoon, then you can directly, instead of having a cathode, you can have the metal spoon as the object. So object has to be either connected to the cathode, or the object itself has to be the cathode. So you have to remember that. Then what do we have here? This will be the electrolyte, that is the salt of the metal to be coated. So these are the conventions. Positive terminal, this becomes the positive electrode. Negative terminal, that becomes the negative electrode. And electrolyte should be the salt of the metal to be coated. So for example, if you want to copper plate something, we use copper sulfate. If you want to silver plate an object, we use silver nitrate. If you are going to gold plate an object, then usually we use gold cyanide. So like that, we use different salts of the respective metal. Then, here you all know the positive electrode, that is the anode. So here we can also say anode should be the metal to be plated. So for example, if you are copper plating the object, this should be copper. So then you all know the object has to be connected to the cathode. So those are the conventions. And in addition to that, students, you all know if we want a very high quality plating, then what should we do? we use a dilute electrolyte solution, and also we supply a small amount of current over a longer period of time, so that the coating will be uniform and also it will be very high quality. So that is another thing that we need to consider. But when it comes to the electrolytic cell, the 4 consideration, the terminals, how the electrodes become positive and negative, what you connect at the anode, the metal, cathode, the object, and what should be the electrolyte solution. So those are the 4 considerations. I'm sure you all can remember that. So with that, students, I'll move on to the next question. Extra question 19. First one, it is required to gold plate an iron object. Write the following in the electrolytic cell used for this purpose. So if you are going to gold plate an iron object, so how do you connect them? The anode has to be gold rod or gold sheet. So it has to be the metal gold. And then cathode is where you connect the iron object. And what should be the electrolyte? A salt of gold. A salt solution of gold. Example I told you all. In the previous question, I told you all gold cyanide. Cyanide is used to gold plate an iron object. Normally, you all know gold is a very inert metal, a native metal, because it's not reactive. It's very less reactive. It is at the bottom of the activity series. But here we can use gold cyanide as the salt solution of gold. So anode has to be a gold rod, cathode is the iron object, and electrolyte is a salt solution of gold. As an example, we can consider gold cyanide. I'm sure you all have written the answer correctly. So with that, students, I'll move on to the next question. Extra question 20. Electrolytic cell used to copper plate an iron object is given below. So you're familiar with this particular electrolytic cell. So here you can see, students, this is the power supply, positive and negative terminals. So when you connect this electrode to the positive terminal, which is the copper plate, and here you can see it is the anode. So that also becomes positively charged. And on this side, we have the negative charge where the iron spoon, that is the cathode, is connected. That is also negatively charged. And here you can see the electrolyte solution is copper sulfate solution. So it is the salt of copper. So you are going to copper plate an object. Object is the cathode. Anode is copper. And the electrolyte solution is a salt solution of copper. That is copper sulfate. So if all the conventions are satisfied here. Then if we look at the questions related to that. Write the reaction taking place at the anode. Near the anode, what happens? The copper plate dissolves. So there is copper solid that gets oxidized to form Cu2 plus aqueous. This happens with a loss of 2 electrons. So Cu solid becomes Cu2 plus aqueous, losing 2 electrons. That is the oxidation taking place at the anode. Then the second one, write the reaction taking place at the cathode. Near the cathode, what happens? It is the reduction of copper ions to copper metal. So there Cu2 plus aqueous take up 2 electrons, forming Cu solid. So here you can remember, students, now copper sulfate is blue in color. You can remember that. So during the reduction, copper ions from the solution deposit on the object. But at the same time, the copper plate dissolves. It undergoes oxidation, providing copper 2 plus ions to the solution. Therefore, the concentration of copper ions in the electrolyte solution does not change. Because of that, the blue color of the solution does not change. So that is something you all have to remember, students. So that is the reason why we always have the metal as the anode. So that continuously the metal to be deposited, the ions will be present in the solution, because the anode will dissolve and continuously provide that ion. So copper ions are used up, at the same time copper ions are provided to the solution. So that is very important. So with that, students, we'll move on to the next slide. Here we have extra question 21. A simple activity to illustrate that air is essential for rusting is shown below. So to show that air is essential for rusting. So here we have boiling tubes A and B. Then what is shown here, you can see in both the tubes there are iron nails. Then there is cold water in tube A and boiled water in tube B. And also above boiled water there is a coconut oil layer. So you are familiar with this particular activity. Now we need to take 2 iron nails which are similar in shape and size. And also you all know, students, when we buy iron nails from the shops, that is the commercially available iron nails, usually they have a zinc coating. I have explained this to you all before in the lesson also. Galvanizing of iron to protect iron from rusting. What do? They dip iron in a bath containing zinc liquid. So there will be a zinc coating over iron nail. To remove that, what do? You all know zinc reacts with hydrochloric acid. So what we do is we soak the iron nails in dilute hydrochloric acid for about 10 minutes and you wash it off carefully with distilled water. So then of course the zinc coating will be removed. You will have the pure iron nails. And then you take water, equal amount of water into both boiling tubes. Into each you add the iron nails, you introduce the iron nails, and then we heat the boiling tube B so that water will boil. And once it does, we immediately add a layer of coconut oil there. So what happens there? When you heat water, when it starts boiling, the gases dissolved in water are evolved out. Why? Because the solubility of gases decreases with increase in temperature. So the gases that were dissolved in water will be released from water. So there will be no air dissolved in boiled water. And by applying or having a coconut oil layer, we prevent the further contact of air with water. So there is no way there is air in this water. So here there is air, here there is no air. Then you will get the observation after few days, 2 to 3 days. What will you all see? You will see that the iron nail in boiling tube A would have rusted, whereas the iron nail in boiling tube B does not rust. So from that we can confirm and say that air is essential for rusting. So where there was air, there was rusting. In this boiling tube where there was no air, there was no rusting. So air is essential for rusting. That is the activity, the observation and the conclusion. So now we'll try to answer the questions. Then, first one, what will you observe in the boiling tubes A and B after 2 days? In A, iron nail rust. In A, iron nail has rusted. In B, iron nail does not rust. So that is the observation. In boiling tube A, the iron nail has rusted. In B, iron nail does not rust. Then the second one. Explain the reason for the observations you mentioned above. So what is the reason? There is air in water in boiling tube A, and there is no air in water in boiling tube B. Because of that, there was no rusting in the iron nail in boiling tube B. So here they explain the reason for the observations you mentioned above. Nail in tube A gets air, but the iron nail in tube B is not exposed to air. Therefore, no rusting in tube B. So that is the explanation or the reason for the answer. Because there is no air, there was no rusting. Then, from the observation, the third one, what can you conclude from the above observation? What can we conclude? The air is essential for rusting. We can conclude and say air is essential for rusting. Air is essential for rusting. Is that okay, student? So I explained the activity to you all and we have answered the questions as well. So what you see is rusting of iron nail in A, no rusting of iron nail in B. The reason is in A there is air, there was rusting. In B there is no air, because of that there was no rusting. So from that we can conclude and say air is essential for rusting. So with that I'll move on to the next slide. That is extra question 22. Here also you can see there is an activity carried out to examine which components in air are essential for rusting is shown below. So in the previous one already we understood that air is essential for rusting. Now we look at this activity where we try to understand what component of air is essential for rusting. So what do we do there? We take two boiling tubes of the same size. Then into one boiling tube, we insert an iron wool. You all have seen this iron mesh or iron wool that is inserted into one boiling tube. Then we take a container, a small vessel, a plastic cup with water, and into that we take a certain amount of water, and in that we invert both the boiling tubes. And after few days, when you observe, what will you see? You will see the iron in this would have rusted, that is the iron wool would have rusted, and also water level would have risen inside the boiling tube that has the iron wool. And also, if you look at the total volume, you will see this is about 1/5 of the total volume of air inside the boiling tube there. And here, of course, there will be no change. So from that, what can you understand? There was iron wool, then there is air, there is vapor in air. So that means both air and water are there for rusting. So that is why iron wool has rusted. And after that, you can understand 1/5 of the volume. 1/5 of the volume is 20% of volume of air. Now you all know in air there is 20% oxygen. So since the water level has risen up to 1/5 of the volume of the boiling tube, that volume is equal to the volume of oxygen in air. So from that we can conclude and say that it is oxygen from air that is essential for rusting. So that is the activity given here. If we try to answer the questions, what will you observe after few days? What will you observe? Iron wool has rusted and water rises up to about 1/5 of the volume in the boiling tube with iron wool. So that is what we need to write. Iron wool rusted, water level rises to about 1/5 of the volume of the tube with iron wool. So that is the observation you get after few days. Then explain the reason for the observation you mentioned above. So here we can say, when iron rusts, it takes up oxygen from air that is 1/5 of the volume of air. So when we say 1/5, that is 20% of air is oxygen. So then, if we look at the last question here, third one, what can you conclude from the above observation? Oxygen from air is essential for rusting. So we can say oxygen in air is essential for rusting. So that is the activity and these are the answers related to the question. So observations, iron wool rusted, water level rises to about 1/5 of the volume of the tube with iron wool. And when iron rusts, it takes up oxygen from air, that is 1/5 of the volume of air. So 1/5 means 20% of air is oxygen. And from that we can conclude and say oxygen in air is essential for rusting. So I am sure students you also wrote the correct answers. So with that I will move on to the next question, extra question 23. An activity carried out to examine whether water is essential for rusting is shown below. So this is another activity which we do to show that, to examine whether water is essential for rusting. To do that, what do? We take two boiling tubes A and B, and for that we need 4 iron nails. And here also students, when you buy iron nails from the shops, those are the commercially available iron nails, usually they are coated with zinc. To remove that zinc layer, what we do is we soak the iron nail in dilute hydrochloric acid for about 10 minutes. And after that, we wash it off cleanly, so that we get the clean iron nails. And thereafter, you take rubber stoppers or cork stoppers and you fix the iron nails like shown in the diagram. One iron nail tip is inside the tube, whereas the other iron nail tip is out of the stopper. Same in both the boiling tubes. And then we take anhydrous calcium chloride into one boiling tube. You all know the function of anhydrous calcium chloride. It absorbs water vapor from air. So what will happen? We have iron nails in both the boiling tubes. In both we have air. But in boiling tube B, because of anhydrous calcium chloride, it will absorb water vapor and there will be no water vapor inside the boiling tube here. So then what will you observe after 2 or 3 days? You will see that in the boiling tube A, the iron nails inside and outside would have rusted. But in boiling tube B, only the part of the nails that are outside the stopper would have undergone rusting. But the part that is inside the boiling tube, that will not rust. So from that, we can conclude and say that water is essential for rusting. Why? Because of calcium chloride, that is anhydrous calcium chloride, absorbed the water vapor from within the boiling tube B. So there was no water vapor for the rusting of iron nail inside the boiling tube B. So because of that, it did not rust. So we can conclude and say that water is essential for rusting. Water vapor or moisture. Water is essential for rusting. I am sure you all can remember that activity, students. So then, let's answer the questions here. So, what will you observe after few days? So, there part of the nails inside the tube do not rust. A and B outside. Iron nails undergo rusting. So in A, both outside and inside, B only outside, iron nails undergo rusting. But in B, part of the nails inside the tube do not rust. That is what you have to write. Then, explain the reason for the observation mentioned above. Boiling tube A, there is water vapor in air both inside and outside. There is water vapor in air both inside and outside for the iron nails to rust. But in boiling tube B, what happens? Part of the nails that are outside have enough water vapor in air. That is why they rust. But the part of iron nail inside the boiling tube does not get water vapor because anhydrous calcium chloride absorbs water vapor. So that is what you need to write there. So to explain what happens, boiling tube A, there is water vapor in air both inside and outside for the iron nails to rust. But in boiling tube B, part of the nails that are outside have enough water vapor in air. That is why they rust. So here that is why they rust. But the part of iron nail inside the boiling tube does not get water vapor because anhydrous calcium chloride absorbs water vapor. Therefore, it does not rust. So here we can include that as well. Therefore, there is no rusting. There is no rusting inside tube B. So only inside tube B the iron nails do not rust. So that is the reason for the observation. So with that, students, I will move on to the next question. This is the third part of the question. So what is the question there? What can you conclude from the above observation? So we saw that this part of the iron nail does not rust because there is no water or water vapor. Rest of the iron nails undergo rusting. Why? There was enough water. So that means water is essential for rusting. That is the conclusion of this activity. Water is essential for rusting. Water is essential for rusting. I am sure you can understand all these, students. With that, I will move on to the next slide. That is extra question 24. The next question, what is rusting? What is rusting? It is the corrosion of iron in the presence of oxygen and water. It is known as rusting. You all know all the metals undergo corrosion. They react with air, that is oxygen in air, there is an oxide layer formed and that is corrosion. But when we say rusting, it is the corrosion of iron in the presence of both oxygen and water. So we have to write that. Corrosion of iron in the presence of oxygen and water is known as rusting. Is that clear, student? So then, the next question. What happens to iron during rusting? And then write the factors required for rusting of iron. What happens to iron during rusting? Iron gets oxidized, or we can say iron undergoes oxidation. You can say iron undergoes oxidation or iron gets oxidized. Write the factors required for rusting. We have already mentioned that in the previous question. Water and oxygen. So when we say water, students, you all know it can be water, the liquid water, or water vapor in air. Either way, water is needed, then oxygen gas. So if you recall all the reactions, what happens to iron? Now we have iron solid. It undergoes oxidation forming Fe2 plus aqueous, losing 2 electrons. This is a note. I'm trying to recall what happens during rusting. So this is the anodic reaction. Or that is the oxidation. Then what happens? We have water, H2O liquid, then O2 gas. They take up electrons forming 4OH minus aqueous. So for that we need 2 water liquid, O2 gas, 4 electrons forming 4OH minus aqueous. This is the cathodic reaction. So that is reduction. Then what happens? Fe2 plus aqueous and OH minus aqueous combine and form FeOH twice. So here if we take 2 Fe2 plus and 4 OH minus, so we need to multiply the first equation, that is the anodic reaction, by 2. So number of electrons becomes 4. So 2 Fe2 plus aqueous plus 4 OH minus aqueous gives rise to FeOH twice. That is also solid. Then what happens? Now this FeOH twice further gets oxidized to form rust. So if we write the oxidation, further oxidation of FeOH twice with oxygen, you can remember there should be 4 FeOH twice solid plus O2 gas gives rise to 2 Fe2O3 dot X H2O, that is also solid, and that is rust. Plus there are 2 water molecules removed, H2O liquids. Now Fe2O3 dot X H2O, that is rust. Fe2O3 is ferric oxide, and here when you have H2O, why do we put X in front? Because we don't know the exact number of H2O molecules present with Fe2O3. So the hydrated Fe2O3 is what we call as rust, and that is a brown color substance, a brown color compound, hydrated ferric oxide. So I'm sure you all can remember that, student. So these are the reactions related to rusting of iron. So you all have to remember the anodic reaction, that is the oxidation of iron, then the cathodic reaction, water and oxygen forming 4 OH minus ions, then the Fe2 plus ions and 4 OH minus ions form FeOH twice solid. But that further gets oxidized. Now this is FeOH twice. 4 FeOH twice solid plus oxygen gas gives rise to 2 Fe2O3 dot X H2O solid, that is the rust, and 2 water molecules. So here, students, we looked at the process where rusting of iron takes place. I explained the anodic reaction, cathodic reaction to you all. Then here I have shown you all this particular reaction where Fe2 plus and OH minus ions combine to form FeOH twice solid. But that particular reaction, if we are to write it as a detailed reaction where we add the oxidation and reduction reactions, you all can remember, students. Now I will do it and show you all. Now when iron oxidizes, there are 2 electrons lost. So because of that, to balance the reaction, we have to multiply that equation by 2. So here we have 2 Fe solid plus we have 2 H2O liquid plus O2 gas taking up 4 electrons, forming 2 Fe2 plus aqueous. That will lose 4 electrons, and when water and oxygen get reduced, you will get 4OH minus aqueous. From this, we can cancel off the 4 electrons here and the 4 electrons there. So here, of course, you have Fe2 plus ions and 4OH minus ions. When they combine together, this combines with this to form FeOH twice. So that is what I have written here. I have just shown the two Fe2 plus ions combining with 4OH minus ions to form FeOH twice solid. But if you are to write the complete equation, that is the cell equation occurring during rusting, we have to use this equation. So I am sure you all can understand that. So here again, to summarize what is happening there, as a note, I gave you all these equations. Iron solid becomes Fe2 plus aqueous, losing 2 electrons. That is the anodic reaction or the oxidation reaction. Then here you can see water, oxygen take up electrons, form OH minus ions. So this is the short reaction I have written where FeOH twice is formed. But when you write it as the cell reaction, what I gave you all now is the reaction. Then here you can see FeOH twice further gets oxidized with oxygen to form rust. That is 2Fe2O3.XH2O, that is a solid. At the same time, water molecules are removed. So this is the reaction related to rusting, students. So with that, I will move on to the next slide. So here we have extra question 25. What undergoes oxidation during rusting? So in the previous question, students, I explained all the reactions related to rusting. So what undergoes oxidation? Yeah, it is iron that undergoes oxidation. Iron undergoes oxidation. Then the second one, what undergoes reduction during rusting? What are the components that undergo reduction? Both water and oxygen together. So here it is water and oxygen. Both of them together take up electrons and form OH minus ions. So they undergo reduction. Then the third part of the question, write the half ionic equations of rusting. They want you to write the anodic half reaction and the cathodic half reaction. So that also I explained to you all in the previous question. So anodic half reaction, Fe solid becomes Fe2 plus aqueous, losing 2 electrons. That is the oxidation or the anodic half reaction. Then the cathodic half reaction, you need 2 water liquid, 1 O2 gas plus 4 electrons, forming OH minus aqueous. That is 4OH minus aqueous. That is the cathodic half reaction. So anodic half reaction, Fe solid becoming Fe2 plus aqueous plus 2 electrons. Cathodic half reaction or the reduction half reaction, 2H2O liquid, O2 gas plus 4 electrons giving rise to 4OH minus aqueous. So those are the reactions in rusting of iron. So I am sure students you all can understand the process of rusting clearly. And you were able to answer these questions correctly. So with that, students, I am going to end this chapter, and in the next chapter also, I will be discussing some more extra questions with you all.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.